Welcome to this explainer. Today, we're going to do something incredibly ambitious. We are going to distill nearly a century of computer science to understand how today's explosive artificial intelligence boom was truly built. It often feels like AI just appeared out of nowhere, literally overnight. But as we'll see, it is the result of decades of intense trial, error, and absolute genius.
Okay, so here's our roadmap tracking the evolution of hardware, algorithms, and data. We'll be covering the dawn of AI, shrinking computers, the AI winning formula, the Big Bang of AI, the corporate AI wars, and finally, the generation era.
All right, let's kick things off with Section 1, the dawn of AI.
Our journey begins back in the volatile mid-20th century. This was a time when the very concept of a thinking machine was actually forged in the fires of World War II. Back in 1939, Alan Turing was tasked with cracking the unbreakable Nazi Enigma code. When traditional methods completely failed, Turing envisioned a totally new kind of machine, which basically became the bedrock for our modern digital world. By 1946, militaries definitely realized the sheer power of computers. But here's the catch. They were powered by vacuum tubes. Think of giant, fragile light bulbs that needed constant manual maintenance. This meant computers were literally the size of entire warehouses. But despite those massive hardware limitations, theorists just kept pushing. In the 1950s, Marvin Minsky, this 23-year-old visionary, actually built the world's first working neural network using wires and just 6 of those highly unreliable vacuum tubes as synapses.
During this same era, Alan Turing was fundamentally questioning the very limits of intelligence. He gave us this absolutely crucial definition in 1950, introducing what he called the imitation game. We now know it as the famous Turing test. It set a benchmark that we are quite literally still chasing today. The question was simple. Could a machine exhibit intelligent behavior so incredibly well that a human genuinely couldn't tell the difference? That profound idea etched the dream of AI permanently into the human psyche.
Moving right along to Section 2, shrinking computers.
So, dreaming of AI and actually building it were two very, very different things. To achieve true intelligence, those wildly unreliable warehouse-sized computers absolutely had to shrink. Step 1, physicist Bill Shockley figures out how to use elements like germanium to create a semiconductor transistor. That shrank computing power down to the size of a kernel of corn. Next, engineers at Fairchild Semiconductor invent the planar process. They basically added a durable coating that made these fragile transistors reliable enough for mass production. Then, Bob Noyce creates the integrated circuit, allowing multiple transistors to finally operate together in unison, kind of like a network. And finally, in 1971, a young engineer at Intel named Ted Hoff realized that to handle super complex calculations, he needed to build a tiny computer itself, the microprocessor.
Now, there is a massive and frankly fascinating family tree behind all of this hardware. Back when Bill Shockley started his company, he was notoriously difficult to work with. This actually led to a mass exodus of 8 brilliant minds, whom Shockley bitterly dubbed the Traitorous Eight. They left and founded Fairchild Semiconductor. As demand exploded, employees eventually started leaving Fairchild to start their own companies, earning the nickname the Fairchildren. We're talking titans like Intel, AMD, and LSI Logic. Get this, today, an astonishing 92% of the world's computing power can be traced back directly to these Fairchildren. Mind-blowing, right?
While the hardware was rapidly shrinking and getting better, software engineers were running their own wild experiments. In 1966, an MIT scientist named Joseph Weizenbaum created ELIZA. Inspired by Marvin Minsky's early neural network, ELIZA used clever pattern matching and substitution to simulate an actual conversation. Sure, it was just an illusion of understanding, but it was so effective that users genuinely felt like they were talking to a real person. It was our very first real glimpse of chatbot intelligence.
Which brings us to Section 3, the AI winning formula.
Fast forward to 1997. Hardware was scaling up and software had gotten incredibly smart. This was proven to the world when IBM's Deep Blue beat the reigning world chess champion, Garry Kasparov. That historic victory revealed the ultimate blueprint for modern AI. It's a formula requiring 3 pillars working in perfect harmony. You need large volumes of data, strong algorithms acting as the models, and massive computing power or compute. Only by combining all 3 of these can you build super intelligent systems. If you're missing even one, the whole system just hits a brick wall and plateaus.
Now, to really improve the model part of our formula, we actually have to rewind a sec to 1986, to a brilliant British computer scientist named Geoffrey Hinton.
He created an algorithm called backpropagation. Instead of just hard-coding rules into a machine, backpropagation acts exactly like a digital teacher. It checks the computer's answers, sees where it went wrong, and adjusts the network so it improves the next time around. This is what allowed neural networks to genuinely learn from their mistakes, and it became the absolute cornerstone of modern AI models.
Okay, on to Section 4, the Big Bang of AI.
Enter the internet age. Explosive data generation from companies like Google, Amazon, and Facebook finally provided our third missing ingredient: massive, essentially limitless data. In 2006, Geoffrey Hinton, who's now known as the godfather of AI, develops convolutional neural networks, which let computers start recognizing patterns in images. Then, in 2007, Dr. Fei-Fei Li launches ImageNet. This was a massive, open-source dataset of images specifically designed to test these algorithms. The real magic happens in 2012. Hinton and his students submit their model, AlexNet, to the ImageNet competition, and it absolutely obliterates the old benchmarks. Data, model, and compute were perfectly aligned. In the tech industry, 2012 is universally referred to as the Big Bang of modern AI.
But wait, what about that final pillar, compute? Well, recognizing the massive 2012 breakthrough, Nvidia CEO Jensen Huang made a truly historic pivot. He bet the entire farm, completely shifting his company away from video game graphics to focus entirely on building AI chips. And wow, did that gamble pay off astronomically. Today, Nvidia secures a massive monopoly, powering a staggering 92% of the world's AI compute.
Let's dive into Section 5, the corporate AI wars.
Once everyone realized the sheer world-altering power of this technology post-2012, the biggest tech titans went to war. It was a fierce, high-stakes battle for supremacy, and it completely split the industry into two distinct philosophical camps. On one side, you had Google aggressively buying up talent, including an AI company called DeepMind, to build a closed-source, for-profit monopoly on frontier models. On the other side, you had Silicon Valley billionaires like Elon Musk, Reid Hoffman, and Peter Thiel. They grew deeply concerned about just one single corporation controlling superintelligence, so they founded OpenAI as an open-source, non-profit organization dedicated strictly to building artificial general intelligence safely.
This arms race escalated dramatically in 2017 when Google invented Transformers. You can think of Transformers as these super smart digital robots that can ingest and read vast amounts of text data incredibly fast. Honestly, this invention was a total game changer. OpenAI quickly realized that to build models using this new transformer architecture, they would need an insane amount of computing power. And that meant they needed billions of dollars. This harsh reality forced OpenAI to broker a massive investment deal with Microsoft, just to stay in the game. It was a major shift toward profit, and it ultimately pushed co-founder Elon Musk to leave the company in protest.
Finally, Section 6, the generative era arrives.
100 million. With tens of billions of dollars injected, and all three pillars, data, models, and compute, maximized to unprecedented levels, the generative AI era finally exploded into public view. In late 2022, fueled by Microsoft's massive compute infrastructure, OpenAI released ChatGPT. It's a chatting, generative, pre-trained transformer. It became the fastest-growing application in human history, hitting 100 million users in just a matter of months, and plunging the entire globe headfirst into the age of AI. Now, get ready for this number: $7 trillion. That is the staggering amount leading AI startups are reportedly seeking in global investment to fund the future of specialized AI microchips and robotic production. The sheer scale of capital and ambition driving this technology forward right now is quite literally unlike anything we have ever seen in human history. So as we wrap up this explainer, we really have to look back at the incredible journey we've mapped out today. From Alan Turing cracking codes with fragile vacuum tubes, to the shrinking of the transistor, to Geoffrey Hinton's digital teachers, and finally, to the massive data centers of today. The century-long quest to perfect that formula of compute, models, and data is essentially complete. So I'll leave you with this profound question. As we stand on the very brink of artificial general intelligence, is this technology ultimately going to save the world or end it? Thank you so much for joining me on this explainer, and keep exploring.